Hey, all, how's it going? Here's going to be our notes for the 2-3 section of our curriculum here. We're going to be proving that lines are parallel, and you're going to notice a lot of similarities between this set of notes and some of the ones that we just recently finished with parallel lines and transversals, because we're going to be using a lot of the exact same vocabulary. So hopefully this kind of comes across as helpful and easy to kind of just progress on from 2.2 to 2.3. So one thing to differentiate is in 2.2, what we were doing is we were saying definitively from the beginning, these lines are parallel, therefore, what can you figure out about the angles? What we're doing in this lesson is saying, here are the angles. Does that tell you anything about the lines? So instead of going from lines, parallel lines to angles, we're being given the angles up front, and then making determinations about whether the lines are parallel or not. So as I go through this, kind of keep in mind the question of like, so for example, on this first one, we're going to be like, is line L parallel to line M? And I know they look parallel and yeah, they're going to turn out to be parallel, but the answer is not always going to be yes. And even though they look a certain way, they might not actually be that way. So as we go through this again, the question is always going to be, is this line parallel to that line sort of deal? So for example, on this first one, if you can find that corresponding angles are congruent. So the big thing here is like, if those corresponding angles are congruent, then the lines are parallel. So if I were to somehow be able to say, okay, angle 3 is 30 degrees, angle 7 is also 30 degrees, those are corresponding angles, I can say, yes, these are parallel. And I would write something along the lines of, we could say, if angle 3 is congruent to angle 7, and I could use any corresponding angles here. I also could have done 2 and 6, 1 and 5, 4 and 8. Remember, corresponding angles are in the same position on their given intersection, so like down and to the right, down and to the right. That's why 3 and 7 are corresponding. They're in the same position. But if any pair of corresponding angles are congruent, then we would say L is parallel to M, using those little parallel symbols in the middle there. So these two lines mean parallel. All right, and then we just do this with all the other ones. If you could find that, say, angle 4 and angle 6, those being alternate interiors. So if I'm like, if angle 4 is congruent to angle 6, then, and it's going to start feeling repetitive, L is parallel to M. All right, 3 and 5 are also alternate interiors, so I could have put angle 3 and angle 5 as well. All right, there's nothing special about 4 and 6. They are not the only alternate interior angles here. And then again, now we're at alternate exterior. What if I was looking at 2 and 8 or 1 and 7, right? Either one of those would work. But if either of those, in this case, angle 2 is congruent to angle 8, then L is parallel to M. And then, all right, so this is going to change. Because remember, with corresponding alternate interior and alternate exterior, you're looking for congruent angles. With consecutive interior and consecutive exterior, you're looking for supplementary angles. So now if I'm looking at angle 3 and angle 6, so it's going to look like this. If angle 3, and let's be real specific here, if the measure of angle 3 plus the measure of angle 6 is equal to 180 degrees, right? That makes them supplementary. If those turn out to actually equal 180, then we can determine that L is parallel to M. And then finally, consecutive exterior. Maybe we're looking at angle 1 and angle 8. They are exterior angles on the same side of the transversal. And the same thing's going to happen here. If the measure of angle 1 plus the measure of angle 8, and of course I could have also done if the measure of angle 2 plus the measure of angle 7, right? Those are also alternate exterior. If that is equal to 180 degrees, then L is parallel to M. So this is just, if you can show that consecutive exterior or consecutive interior are supplementary, then those lines are parallel. If you can show that alternate exterior, alternate interior, or corresponding angles are congruent, then the lines are parallel. So that's kind of how we're pursuing this. So here's some examples here. So the question is L parallel to M? And the answer is either yes or no, or maybe we don't have enough information. And we should be able to use some sort of converse that was just introduced to us. These converses are a type of mathematical statement that we can sort of use to prove things. So if we can use one of these converses to show that these lines are parallel, then we can make a determination. And right here on this very first one, I have two angles that hopefully we recognize as alternate exterior angles that are congruent. They're both 63 degrees. And because those angles are both 63 degrees, then line L is parallel to line M. So the question, is L parallel to M? The answer is yes. If yes, state the converse that proves this, and this is going to be the alternate exterior converse. Okay? These two lines, moving on to number 2, these two lines indicate that these two angles are parallel. Or not parallel, sorry, these two angles are congruent. Sometimes you see little hash marks on them, but sure enough, this indicates congruency, and those are corresponding angles. So we can say that L is parallel to M, and the reason is we have corresponding angles that are congruent. All right, next up, we have two angles here, 48 and 32. Now, these are consecutive exterior angles that we actually expect to add up to 180. So what I'm going to do is I'm going to take 132, I'm going to add 48 to it, and I'm going to see what that adds up to. And it turns out that that does indeed equal 180. So once again, L is parallel to M, and in this case, we have these two supplementary angles. Those are consecutive exterior. All right, now the next one, 105 and 105. That's great. Those are congruent. They're vertical angles. But the problem is these two angles are on line M. There is no information given about line L. So our transversal, which crosses both L and M, might create congruent angles down here. As a matter of fact, it creates congruent angles up here too. All vertical angles are always congruent. The problem is we don't know what this measure is. There is not enough information to find out. So we're going to say not enough info. There's no angle up here to tell us. Like if this were also 105 or this were also 105, then we would be able to say something. We'd be like, all right, these are corresponding, or these are alternate exterior, or these are alternate. We would have some information to go on. But because there's no given angles right here, we don't have enough information to make a determination about L and M. Next up, we've seen this before. Those are alternate interior angles, and they are congruent as indicated by those arches. So we are going to say, yes, L is parallel to M because of alternate interior converse. They're congruent. And then finally, we've got this one. We have the 125, and I'm going to add that to 65. And the reason I'm adding these is because I would expect these types of angles, which are consecutive interior angles, to add up to 180. There is a problem here, though. If I were to work through this, 5 plus 5 is 10, raise that 1, oh dear. 1 plus 2 plus 6 is 9. These add up to 190, not 180. So don't let your eyes deceive you. These sure look parallel, but they are not. So what we're going to say is L is not, look, all we got to do is put a little slash through that parallel symbol, is not parallel to M. And we can actually, this is actually something that we can prove is not parallel. So on number 4, I was like, there's not enough info. On this one, there is enough info to prove that these are not parallel because those are not supplementary. They are not parallel. And that relationship is the consecutive interior converse. All right, moving on. So there's a bunch of different questions here, like, geez, what is that? 9 different ones. And we're going to say, hey, let's look at these angles. Given what we know, are they parallel? And we got P, Q, and R all here. And I'll work through a few of these, maybe all of them. We'll see. All right, first up, angle 9 and angle 22. Those are being told to us are congruent. If they are congruent, then I can say that Q is parallel to R because those are congruent alternate exterior angles. Next up, we have 8 and 13. And it says that those add up to 180. And if that is true, which that's the given, we have to assume that they're not lying to us, then P is indeed parallel to Q because according to the given, and givens are supposed to be taken at face value. It's not like they lied to us. So if 8 plus 13 equals 180, then they are indeed parallel because those are consecutive interior angles, and consecutive interior angles are supplementary, meaning they better add up to 180. All right, 1 and 17. If those are congruent as given to us, then P, which is the line, so we got this transversal, and we got line P, and then down here we have the same transversal S and line R. Those are corresponding angles, which means P and R are parallel because of corresponding angles. You can kind of see where we're headed with this. A lot of this is going to feel, at this point, a bit repetitive, but let's see if I can kind of speed through this. So next up is 16 and 20. 16 and 20 are down here. 16 is on line Q. 20 is on line R. These are alternate interior angles. So Q is going to be parallel to R because of alternate interior. Next up, 2 and 22. So 2 is way up here on P, 22 is way down here on the exterior, is worth noting, of R, both using transversal S. So those are consecutive interiors, and if they add up to 180, then sure enough, P is parallel to R because these are consecutive exterior angles. 10 and 13. 13's here, 10 is here. It says that those are congruent. Now, 10 and 13 actually do have a relationship with each other. They are on a transversal Q, and Q is intersecting lines S and T. Now, they are, it turns out, if you were to like turn the page, you might, like 90 degrees, it might be easier to see this, but these are consecutive interior angles. So if you use S and T, these are interior of S and T, and they are on the same side of transversal Q. We would expect consecutive interior angles to be supplementary, not congruent. So there's actually not enough info on this one. There is a world where congruent angles, consecutive interior angles, are congruent, and that's only if both of them are 90 degrees. Now, looking at these, they don't look 90 degrees, but I don't want you to start judging things based on how they look. So we're just going to say there's not enough info and move on to the next one. 3, which is up here, and 22, which is down here. Now, these are, if I look at P and R, these are both down and to the right of their respective intersections, which means that these are corresponding angles. So are they congruent? Yes, they are. Which means that P is parallel to R because of the corresponding angles converse. 15 and 5. 5 is here, 15 is here. Those are alternate exterior angles. So we've got 5 exterior of line P, 15 exterior of line Q. They are on opposite sides of transversal T. It says they're congruent, which means that P is parallel to Q because those are alternate exterior. And finally, we got 2 and 16. 2's over here. 16 is over here. Well, y'all got ourselves a problem because 2 is the intersection of S and P. 16 is at the intersection of T and Q. These two angles do not share a line. There's no transversal that's going from 2 to 16. 2 has these two lines over here that don't touch 16. 16 has T and Q, which doesn't touch 2, which, y'all, once again, this means we do not have enough info. Not enough info. And that's kind of how problems like that go. Sometimes you can say these are definitely not parallel, kind of like we did on number 6 on the previous section. But yeah, usually it's like we just don't have enough info. We can't make a determination. Maybe they're parallel, but this intersection over here tells me nothing about like this intersection, and this intersection doesn't tell me anything about this intersection without more information, which is why I put not enough info. Okay, transitive property of parallel lines. What transitive property means, if like something is equal to something and something is equal to, and that thing is equal to something else, then the first things are equal, which I'll draw like a little picture. So if I have line P and it is parallel to line Q, so that's like a given. These are parallel. And then I have line R and line Q are parallel. It only goes to reason that if the green lines are going in the same direction and these little, purple sections are going in the same direction, then that means R and P are also going in the same direction. So we could determine that P is also parallel to R. So if P is parallel to Q, Q is parallel to R, then P is also parallel to R. So we're going to use that information to figure out some things about all these lines over here. We are being told that A and C are parallel. Let's use these other angles to see if anything else is parallel. And remember, in order to compare angles, we need to know that they are on the same transversal. So these two angles are on this vertical transversal here, and 108 and 62 are on the transversal over here. So I'm basically just going to add these things together, see if they add up to 180, because these are consecutive exterior angles. These are also consecutive exterior angles, and consecutive exterior angles need to be supplementary to prove any type of parallelness. So here we go, 84 plus 96, that's going to add up to 10. Carry the 1, that's 9 plus 9, which is 18. That's 180, y'all. So I can say, let's use a different color here, that B and C are parallel because we had those consecutive exterior angles being supplementary. Let's go over to this other one, 108. You're probably already looking at that and being like, Mr. Riley, don't bother. That doesn't equal 180. Because you're right, that equals 170. And that's enough to prove that C and D are actually not, just straight up not parallel. So I could, C is not parallel to D. So here's what we know. A is parallel to C. B is also parallel to C. Since both A and B are parallel to C, that means that A is also parallel to B. And that is what the transitive property tells us. And it does ask us to say why. So let's throw in some other stuff here. How do we know that A is parallel to C? That was a given. How do we know that B is parallel to C? That is because of consecutive exterior angles. And how do we know that A is parallel to B? That would be the transitive property that was just introduced on the panel to the left. All right, ladies and gentlemen, that's the end of the notes. Hopefully those were helpful and informative. There's going to be homework obviously tied to this. And if you have any questions, come find me in tutoring. And until then, I will see you in class.